Hello everyone, welcome back to Concept Branch with Riddhi, your one-stop solution for mastering mathematics. Today we are diving into exercise 8.3, question number 4 from class 10th NCERT textbook on trigonometry. We'll solve all parts from 1 to 10 step by step, making it super easy to understand. What is in today's class? In this question, we will use trigonometric ratios like sine, cosine, tangent and trigonometric identities and other formulas to solve problems involving triangles. These exercises will help you strengthen your foundation for trigonometry and prepare for your exam. It's important. This is one of the most important exercises in chapter 8 as it tests your understanding of the concept and how to apply them in different scenarios. Don't worry, I will guide you through every step. This is our first question in that we have to prove LHS equal to RHS, correct? Let's take the LHS first. Write it down. Cosec theta minus cot theta whole square. Okay, in this question we have to write all the values of cosec theta and cot theta in the term of sine and cos. We can do so many ways. This is the easiest way how we can do that. Okay, so on the place of cosec theta we can write 1 over sine theta minus, on the place of cot theta we can write cos theta divided with sine theta whole square. Okay, next take an LCM sine theta and on the top we can write 1 minus cos theta whole square. Okay, so what we can write 1 minus cos theta whole square, and in the down we can write sine square theta. We know the identity sine square theta plus cos square theta, that is equal to 1, right? So instead of sine square theta we can write 1 minus cos square theta. Okay, so I'm replacing the value over here. So 1 minus cos theta whole square, instead of sine square theta we can write 1 minus cos square theta. Okay, here there is a two different formulas we can apply, that is a minus b whole square we can write as a minus b times a minus b, and in the down we can write a square minus b square we can write as a plus b times of a minus b. So in the denominator if you see, instead of 1 we can write 1 squared minus cos squared theta. So what we can write, 1 plus cos theta times of 1 minus cos theta. Okay, so just write all the values. 1 minus cos theta times 1 minus cos theta divide with 1 plus cos theta times 1 minus cos theta. Cancel the value. So finally we get the answer as 1 minus cos theta divided with 1 plus cos theta. If you'll check it, this is our RHS, hence proved. I'll give you a suggestion for the formulas. If you don't know, if you don't make it remember, just make a table for that in any chart paper and paste before you. Whenever you're solving the questions, apply it directly while seeing. Once you'll start practicing, it will fix to your mind. Okay, this is our second question. In that again we have to prove LHS equal to RHS. Okay, so again take the LHS part and we'll solve it. Okay, so this is the question in the LHS. Okay, so take an LCM for that. Okay, so 1 plus sine A times cos A. Okay, this is an LCM. Now, okay, let's see how to take LCM. Sometimes students are confused. Suppose this is the thing to take an LCM. Okay, so what is LCM? So we'll first multiply B times D, then we'll divide the B with BD. Okay, we'll divide the B with BD. Okay, so what is the remaining? D will be remaining, correct? So after that we'll multiply the D with the A, so it will be 80, correct? Now next step, now we'll divide the D with BD. Okay, so DD will cancel out, remaining will be what? The B, right? And we'll multiply the B with C, so your answer will be BC. Okay, like that we do. Similarly we'll do it here as well. Now we'll divide 1 plus sine A with the whole thing. Okay, what is remaining? Cos A, and we'll multiply this cos A with this cos A, so it will become cos square A. Is that clear? If you don't, just move it back. Okay, so this will become cos square A. Similarly, over here, what we will do? We'll divide this cos A with the whole thing. So cos A cancel. What is remaining? 1 plus sin A. And we'll multiply this sin A with this one. 1 plus sin A. Okay. So what is the answer remaining? 1 plus sin A whole square. Okay. Easy, right? Let's expand it now. So when you will expand it, it will become cos squared A plus 1 plus 2 sin A plus sin square A, correct? And divide with 1 plus sin A times cos A. Okay. How I expanded? I applied this A plus B whole square. So what will be? A square plus B square plus 2AB. I applied this over here. Okay. Now next step, what we can write? See, over here we can use an identity. Cos square A plus sin square A we can write as a 1. Okay. So 1 plus 1 plus 2 sin A divide with 1 plus sin A times of cos A. Okay. Next. So we can write from here 2 plus 2 sin A divide with 1 plus sin A times of cos A. Okay. Now what will be? We will take 2 as a common. What is the remaining? 1 plus sin A divide with 1 plus sin A times of cos A. 1 plus sin A, 1 plus A sin A cancel. So it will be remain 2 over cos A. And 2 over cos A we can write as a 2 secant A. And this is your RHS. Right? This is our third question. In that we have to prove LHS equal to RHS. Right? So in the LHS part, what we are going to do, we are converting sine and cot in sine and cos. Okay. So on the place of tan theta, can we write sine theta divide with cos theta, correct? Divide with 1 minus, on the place of cot theta, we can write as a cos theta divide with sine theta. Clear? Next. On the place of cot theta, we can write as a cos theta divide with sine theta. Then minus, in the denominator we can write 1 minus sine theta divide with cos theta. Clear? Now what we can do? We can take an LCM and we can fix it. Correct? So what I'm going to do? See, sine theta divide with cos theta and sine theta. This will be sine theta minus cos theta, and over here this will be cos theta divide with sine theta, and this will be cos theta minus of sine theta and divide with cos theta. Okay. Next step, what we can do? We can write in a simple way sine theta divide with cos theta, and it will flip it, right? So it will become sine theta divide with sine theta minus of cos theta. Similarly, this side also it will be happen same. Cos theta divide with sine theta. Flip it again. Cos theta divide with cos theta minus of sine theta. Correct? Let's rearrange this step. So here we can write as a sine square theta divide with cos theta times of sine theta minus of cos theta. Correct? Over this place, if you'll see here, this is cos theta minus sine theta, right? So it means this is not the correct way how it is, right? So for this, making it same, we'll take minus common here. So sine theta, take minus common, it will become sine theta minus of cos theta, correct? Now it looks similar, right? Now on the top it will become cos square theta. Even one more thing, just look at this. This is minus, this is plus, so plus times minus will become minus, so it will change the sign, correct? So what I'm going to do, I'm going to change the sign here. Look. So the sign will become here minus. Clear? Now let's take an LCM. Okay, before discussing this LCM, I'll discuss something else. Suppose we have AB and BC. Okay, if I'll say take an LCM for this, what will be the LCM? The common part we will write once, correct? So the LCM will be ABC. Similarly, here as well, see what is the repeating part here? Sin theta minus cos theta is repeating. So we'll write it once. Okay, so the LCM is going to be sin theta time of cos theta times of sin theta minus of cos theta. Okay, now what I'm going to do, I'm going to divide this whole with this. Okay, if we'll divide this, what is remaining? Sin theta is remaining, and multiply this sin theta this with this. Okay, so what it will become? It will become the sin square theta, and sin theta will become sin cube theta minus. Similarly, what I'm going to do, I'm going to divide this whole with this. Sin theta and sin theta minus cos theta will cancel out. Remaining is cos theta, and multiply with this cos square theta will become cos cube theta, right? Just write it here, cos cube theta. Now we can see here a cube minus of b cube. We can apply this formula here. Okay, so what is going to be the formula a cube minus b cube? It's going to be a minus b times of a square plus ab plus b square. Okay, so let's apply it here. So it's going to be sin theta minus cos theta times of sin square theta sin theta times of cos theta plus cos square theta, correct? And in the down we can write same thing, no change at all. Sin theta times of cos theta times of sin theta minus of cos theta. Okay, now over here sin square theta plus cos square theta is an identity, so we can write 1 plus sin theta, like this is 1, and so answer will be what? C. And one more thing, sin theta minus cos theta we can cancel out, so these two will be 1 plus sin theta times of cos theta divide with sin theta times of cos theta, correct? Although they can ask you the answer like that also, but according to our question we have to move little bit more. So just separate them. Sin theta times of cos theta plus sin theta times of cos theta divide with sin theta times of cos theta. So even we can separate more. So 1 over sin theta times of 1 over cos theta plus 1. So here we can write cosec theta times of secant theta plus 1. So rearrange it everything. So 1 plus secant theta times of cosec theta, and this is your RHS, hence proved. This is our fourth question. In this question you can see this is our LHS part and this is our RHS part, right? So if you can see the question hint, they said that we can separately we can prove it, right? So let's do that accordingly. So in the LHS, this is in the term of secant, right? Let's convert these two in the term of cos. So what is going to be 1 plus 1 divide with cos A and divide with 1 divide with cos A, right? So what is going to be cos A plus 1 divide with cos A, and this is 1 over cos A, right? So cos we can cancel out, so it will become cos A plus 1. In the RHS part, the sin square A, on the place of this we can write 1 minus cos square A. How? Because sin square A plus cos square A is 1. So on the place of sin square A, what we can write? We can write 1 minus cos square A. Just write it. So it will be 1 minus cos square A divide with 1 minus cos A, right? So again we can use the formula a square minus b square, we can write a plus b times of a minus b, right? So 1 square minus cos square a. See, this one we can write as a 1 square, right? So what we can write here? 1 plus cos a times of 1 minus cos a, right? So just write it here. It will be 1 plus cos a times of 1 minus cos a and divide with 1 minus cos a. Cancel this 1 minus cos a. So what is remaining? 1 plus cos a. So we can see from here they both are equal. So we can say LHS equal to the RHS. Okay. In this question we have to prove LHS equal to the RHS, right? So in the LHS we have to use the identity cosec square a minus cot square a equal to 1 as it's given in the question as well, right? Let's do that. So what I'm going to do is I'm going to divide the sign up and down. Okay, I'm going to divide it up and down with the sign a. Let's see the magic. So what is going to be? Cos a divide with sin a minus sin a divide with sin a plus 1 divide with sin a. This was the numerator. Now denominator. Cos a divide with sin a plus sin a divide with sin a minus 1 over sin a, right? So what will be? Cos a divide with sin a will become the cot a, right? So we did all these things to convert into the cot and cosec, right? So this is cot a, sin a divided by sin a is minus 1 and 1 over sin a is cosec a, right? Down. Cos a divided by sin a is cot a, this is plus 1 and minus of cosec a, correct? Now what we are going to do is we are writing on the place of the 1 we can write what? Cosecant square a minus cot square a. This is the identity we are going to use it here. So what will be? Cot a plus cosecant a, right? Minus. So on this place we are writing value. Okay. So what will be? Cosecant square a minus of cot square a. In the denominator, I'm not going to do anything. Leave it like this. Cot a plus 1 minus of cosecant a. Okay. Now again, if you can see, this is the a square minus b square. So on the place of this, we can write a plus b times of a minus b. So cot a plus cosecant a minus cosecant a plus cot a, and it will be cosecant a minus of cot a. If you can see, something is common here. What is common? Just look at them. Till then I will write the denominator cot a plus 1 minus of cosecant a, right? Next, what is the common? See, these two parts are common, correct? We can take common from here, right? So let's take common. Cot a plus cosecant a is common. If we took everything common from here, what is the remainder now? We can say it's 1 minus this part is remaining, right? It will change the sign. Let's change the sign. So plus will become negative and negative will become positive, right? And leave the denominator like that. Okay. Okay. So can we see these two are the same thing? We can cancel, right? So remaining is cot a plus cosecant a. That is equal to our RHS, hence proved. This is our 6th question. In this question, we have to prove LHS equal to RHS, right? Let's take the LHS part. Over here, what we are going to do is, we are going to do rationalization, okay? So, 1 plus sin A divide with 1 minus sine A. What we are going to do? 1 plus sine A divide with 1 plus sine A. Okay, what will be 1 plus sine A whole square and 1 square minus sine square A under root. Correct? Why we did like this? Because we can remove the square root. Correct? Now 1 plus sine A whole square and 1 minus sine square A, what we can write? We can write cos square A, because why? Using the identity, right? So this will become cos square A. Now we can easily remove the root. So what is remaining? 1 plus sine A divide with cos A. Separate them. 1 divided by cos A plus sine A divide with cos A, right? So what is going to be? 1 over cos A will become the secant A, and this will become the tan A, that is equal to RHS, hence proved. This is our 7th question. In this question, we'll take the LHS and we'll prove till RHS, right? If you can see, easily we can take sin theta common here and cos theta common here. Let's do that. So if I'll take sin theta as a common, what is the remaining part? 1 minus 2 sine square theta. And in the denominator, same thing we are going to do. We are going to take common cos theta and 2 cos square theta minus 1. On the place of the 1, I'm going to use the identity. Sin square theta plus cos square theta. Sin theta divide with the cos theta. Now let's use it. 1 will replace with sin square theta plus cos square theta minus 2 sin square theta. Correct? In the denominator, 2 cos square theta. Due to this minus sign, it will change the sign of identity. So it will become minus for both. Okay. So sin theta divide with cos theta. Sin square theta minus 2 sin square theta. It will become what? It will become the minus sin square theta. Correct? Similarly, cos square theta minus 2 cos square theta minus cos square theta will become the cos square theta minus sin square theta. Up and down it's same, we can cancel out, right? So remaining is sin theta divided with cos theta. It will become the tan theta, which is equal to our RHS. Okay. This is our 8th question. Again over here we have to prove LHS equal to RHS. Let's do that. It's very easy here. We can apply a plus b whole square here and here as well. Correct? Let's do this. Okay. Expanded the LHS. Sin squared a plus cosec squared a plus 2 sin a times of cosec a. Now second part. Cos squared a plus secant squared a plus 2 cos a times of secant a. If we can make a correlation, sin squared a plus cos squared a, we can write as a 1. Sin and cos are opposite to each other, right? So this can cancel. We can write the 2. Now, cos and secant are opposite to each other, can cancel and write the 2. Remain part is cos squared a and secant squared a, right? Write it here. Cosec squared a plus secant squared a, right? This will become 5. Cosec squared a, what we can write? 1 plus cot squared a, and on the place of secant squared a, we can write 1 plus tan squared a, right? 5 plus 1, 6 plus 1, 7. 7 plus cot squared a plus tan squared a, and this is equal to our RHS, hence proved. This is our 9th question. In this question, you can see the situation is a little bit not okay, right? What we'll do is, we will separately prove it, right? Let's do that. So this is our LHS and this is our RHS. Okay. Let's convert this RHS in the term of sine and cos, and that part will convert here as well, right? So in the LHS we can see, not LHS, sorry, RHS, 1 over tan A plus cot A, right? Let's convert into sine and cos. So it will be what? Sine A divided with cos A, and this will be cos A divided with sine A. Okay, next write it down. This is 1. Over here we can write as a LCM sine A times of cos A. So cos A and cos A will cancel out, remaining is sine A, and multiply with the sine will become sine squared A. Similarly here it will become the cos squared A, right? So sine squared A plus cos squared A is 1, and it is remaining sine A times of cos A. So this is basically the RHS. Now we have to convert this LHS in the term of RHS. Let's do that. Okay, for that what I'm going to do is, we can convert the cos in the term of sine. Okay, and similarly here as well, let's do that. So we can write 1 over sine A minus sine A, 1 over cos A minus of cos A. What will be? 1 minus sine squared A divided with sine A, and here it will be 1 minus cos squared A divided with cos A, correct? Let's do that now. So 1 minus sine squared A we can write as a cos squared A divided with sine A, and here we can write as a sine squared A and divide with cos A, right? Easily we can cancel, right? So what is the remaining part? Easily we can write cos A times of sine A, right? This is equal to the RHS. So hence we can say LHS equal to the RHS, okay? So this is our last question, right? Here you can see there is a 3 part, the first, second and the third part, right? So first we'll prove first equal to third. Let's do that. So you can see here this is 1 plus tan square A, we can write simply as a secant square A, right? And 1 plus cot square A we can write simply as a cosecant square A. Okay, now the secant square A we can write as a 1 over cos square A, and sine we can write as a cos we can write in the term of sine square A, right? Let's rearrange it. So it will become sine square A divided with cos square A, which is equal to the tan square A. So the first part became the third part now. This part is done. Now let's do the second part. What's the second part says? 1 minus tan A divided with 1 minus cot A whole square, correct? What we will do? Let's convert the tan and sine and cos. So 1 minus sine A divided with cos A, 1 minus cos A divided with sine A whole square, correct? Next, take an LCM. Okay, so cos A minus of sine A divided with cos A, and here sine A minus of cos A divide with sine A whole square. Let's rearrange it. Cos A minus of sine A divide with cos A times of sine A divide with sine A minus of cos A whole square. If you can see this part and this part, there is a minus 1 common, then we can cancel easily, right? Let's do that now. So cos A minus sine A times of sine A, right, divide with, I'm taking minus common from here, so minus of cos A, it will become cos A minus of sine A whole square, correct? Next, we can cancel easily. So what is the part remaining? Sine A divided with minus of cos A whole square. Minus minus will become plus, and remaining is what? Sine square A divided with cos square A, which will equal to the tan square A, and this is our third part, hence proved. That's it for today's video. We have successfully solved all 10th questions for exercise 8.3 of class 10 CBSE. I hope this was helpful and gave you a clear and understanding of the concepts. In the next video, we will tackle some more advanced concept on trigonometric identities. So stay tuned for that. If you have any question, doubts or suggestion, feel free to drop them in the comment box and I will do my best to address them. Thank you for watching and don't forget to like, share and subscribe for more math content. See you next video. Bye bye.